Hello everyone and welcome to Online Lecture 14. This is your Exam 1 review. So first, just a couple of quick reminders for you. Remember that you will need access to your calculator, Zoom with video, D2L, and your one-page front and back optional note sheet. Okay, now if you decide to go for the note sheet, and I expect pretty much all of you will, please remember you need to turn in your note sheet at the end of the exam. You will be turning it into the assignments area under D2L. Okay. Also, please remember that you need to be on time for the exam. You're just going to want to do that to make sure you have enough time to devote to it. Okay. All right, so let's start with a little bit of a lighthearted review, and then we'll get to the more serious points. So what is X bar? A place where X's go to meet and have fun. What an easy exam. So of course, X bar is what? It's the sample mean. It's the sample mean. So if you're struggling with symbols, maybe that's a good thing to put on your actual note sheet. X bar is the sample mean, whereas mu is the population mean. Okay. My average student is doing great. Half my class thinks 2 plus 2 equals 3, and the other half thinks 2 plus 2 equals 5. I guess the idea being that the average would be 4, right? So misuse of the average. Not everything makes sense to take a mean for. And we talked about that, right? We talked about when you might want to use a median, when you might want to use a mode. So keep those things in mind. Okay, here we have some offices in the statistics department with room numbers 404 for the main department office. Dr. Blumenthal is 419, Dr. Miller's 412, and at the end we see the mean is 421.17 and the standard deviation is 12.54. Another misuse of statistics, right? These are not things, these are kind of more nominal type pieces of information, and it's not something we'd want to take the mean or standard deviation for. Okay. In retrospect, it was clear why Jack was bragging about the mean height of his beanstalks rather than the median. Ooh, sorry about that. Okay. In retrospect, it was clear why Jack was bragging about the mean height of his beanstalks rather than the median. So why is he bragging about the mean rather than the median? Well, you can see he has this one relatively large outlier beanstalk, and if he actually included that outlier in his mean average, he would get a much bigger number than if he simply took the median. And that's why sometimes when we have really extreme outliers, we prefer to take the median. Okay. Symbols. Okay, so I invite you to look back and see if you actually know these symbols. And then we'll go through each of them in turn. So think about what mu is. We just talked about it. Population mean. How about X bar? Sample mean. How about sigma squared? Population variance. And if sigma squared is population variance, then sigma must mean population standard deviation. Going to the other side, S squared is your sample variance, and S is your sample standard deviation. N, sample size, right? How many are actually in the sample? That next symbol there, remember what that is? That's your alpha. P is probability. Z refers to our z-score. And our last symbol here, that funny looking one, means summation. Add them all up. Add them all up. Okay, so now we turn to the third part and the final part of our review, which is exam examples. The following 5 questions are examples of the sort of questions that could be asked on the exam. At least one of these 5 questions will appear on the exam. Now, I want to point something out to you before we even look at the questions. I say at least one of these will appear on the exam. Others might appear exactly on the exam. Others might appear in a different form on the exam. So please make sure always when you're taking my exam or really any exam to please read the questions very carefully. Don't just look at the stem and say, oh, this is the one and this is the answer. But I do promise you one will appear exactly the same as here on the exam. Okay. The mean score on a creativity test is 30. And the standard deviation is 5. The distribution is normal. Using the percentage approximations for the normal curve, approximately what percentage of people would attain a score between 20 and 40? So I invite you now to pause and try to figure out the answer. Okay, if you said D, 95%, then you were correct. Now, how did we figure this out? Well, if you remember, this goes back to the 68, 95, 99.7% rule of thumb that we were looking at with normal curves. And the way that rule worked is that if you were 1 standard deviation up and down, you covered 68% of the population. If you were 2 standard deviations up and down, you covered 95%, and 3 standard deviations mean you covered 99.7% of the population. So how many standard deviations are we here? Okay, well, we're looking from 20 to 40. If we were looking from add 5, 35, subtract 5, 25 from 30, right? Then we would cover 68% of the population. But since we're adding 5 twice, the standard deviation twice, to 30 to get 40, and since we're subtracting the standard deviation twice, 10 to get 20 from 30, we are covering 95% of the population. Okay, so had this said 25 to 35, we would have been answer C. Had it said from 30 to 35, it would have been answer A. Had it said anything 30 and above, it would have been answer B. Okay. The correct answer was D, 95%. Okay. Jill's Z-score for swimming ability is 0.40. What is Jill's raw score, assuming mean of 100 and standard deviation of 9? So if you don't already have your formula sheet out, I'm going to recommend you pull it out for this particular example. Okay, so let's talk this one through. The answer was A, 103.6. Now, this is a situation where we're trying to get the raw score and we already have the Z-score. So this is where knowing symbols comes in really handy. I'm going to switch my share for just a moment so you can actually see the formula sheet and we can talk this through together looking at that. Okay. So looking down, we know it's one of these 2 formulas by the Z-score, right? We know it has something to do with Z-scores. On the left, we're trying to calculate a Z-score. On the right, we're trying to calculate an X, a raw score. So we are going to use the formula on the right. Next, you have to multiply your Z by your standard deviation and then add your mu. So multiply Z by your sigma or standard deviation and then add your population mean. Okay. So let's switch back to the data so we can look at this. So what are we doing? We're taking z times standard deviation, 0.4 times 9, which gives you 3.6, and adding it to our mean of 100. 100 plus 3.6 gives us 103.6. Okay. Suppose that a researcher wants to know if a new flu drug affects people by making them better. Would this be a one-tailed or two-tailed test, and why? Pause, take a moment, and then I'll tell you the answer. Okay, the answer is B, one-tailed, because there is a predicted direction of the effect of the drug. Now that's the only thing you have to really worry about when deciding whether something is a one-tailed or two-tailed test. Is there a predicted direction or not? In this case, we predicted, the researcher wants to know if it's going to make people better, right? Better, improved. We're predicting a direction. If we had said by making them different, that would have been two-tailed. Okay. If the new flu drug would affect people in some way, not specific, two-tailed. But when you see a direction, it's one-tailed. Okay. You want to study the general amount of drug use in a local high school. You randomly select a sample of all homerooms and administer your drug use survey to all students in the randomly selected homerooms. This is an example of what? Okay, so take a pause. The answer is D, cluster sampling. Cluster sampling. So why is that the case? Okay, so we assumed that our local high school is randomly already broken up into homerooms. So we took a sample of homerooms. And here's the real big key. I gave the drug use survey to all students in those randomly selected homerooms. That's how you know it's cluster sampling. Everybody in the selected bigger group of homeroom got the survey. With simple, we would have put all the students' names in a hat and randomly selected some. With systematic, we would have gone ahead and chosen maybe every 10th student, starting with number 4. We're stratified. We would have broken up students, maybe by year in school, freshman, sophomore, junior, senior, and then took a proportionate simple random sample from each one. Now note, with the stratified, we would have still been pulling names out of a hat. We just would have had 4 hats. One for freshmen, one for sophomores, one for juniors, one for seniors. But we're still pulling people individually. With cluster, once we choose our homerooms, it's everyone in those selected homerooms. Okay, so this was cluster. You conduct a research study where the results show that the sample of older people have higher scores on introversion scale than a sample of younger people. Higher scores indicate higher levels of introversion. What conclusion could you reach? Take a pause. And I'll tell you that the answer in this case is A. Age, being old versus young, is associated with introversion. Why isn't it B as well? Or why isn't it B at all? Why can't we talk about causation here? Being old causes higher levels of introversion than being young. It's really the causes that's throwing us off. And the reason we can't talk about causation is we did not manipulate the independent variable. We did not manipulate the independent variable. In other words, we didn't say, okay, you're in my study and you'll be a young person. And you're in my study and you'll be an old person. Well, I can't decide who's old and who's older and who's younger. People just come that way, right? I can't put people into my groups that way. And because I can't manipulate that independent variable, I cannot talk about causation. So I can talk about association, and that's why A is the correct answer, but I can't talk about causation. Okay. So that's it for the questions. As promised, one of them, just as it was here, will appear in the exam. It's possible the answer choices will be in a slightly different order, but the exact question and the exact answer choices will be there. Maybe more than one will appear in the same or in a different type of form. So read all questions carefully, please. Finally, I want you to notice only 2 of the questions, questions 1 and 2, dealt with numbers, and only 1 involved you using a formula. Now, I'm not saying there won't be any formulas or any numbers on the exam. There certainly will be, but I want you to be prepared for the questions like the last 3 I showed you, the conceptual questions as well. So please bear that in mind as you are studying. I wish you the best of luck, and I will talk to you next time. Stay safe and healthy.